Hi, my name is Yanan. I'm a PhD student at the University of Wisconsin-Madison. This work is in collaboration with Ruobin, Wang, Crescentia, Jung, and my advisor Yea-Seul. We were investigating how to make web data table more accessible. Data tables are popular in many online documents, including news articles and government reports, and online applications such as bank statements. According to prior research, data tables are one of the most common data representation types, followed by bar charts. Tables are a great media for sighted people to understand the structure and contents of the data. They use lots of visual metaphors. For example, on the left table, you can see the merge cell. The merge cell not only provides information that four cells have the same value, but also convey the hierarchy structure that four responses belong to viewer crashes, for example. And you can see the empty cells, where sighted people immediately notice it is missing values because it's empty. The table on the right side uses other types of visual metaphor. For example, the merge cell in the middle that spans across all columns works as a separator. It separates the table on the top and the bottom. As you can see, table in the wild use many visual metaphors that sighted people can easily notice. Those metaphors facilitate the understanding of structure without explicitly explaining complex structure. But you can imagine how hard it would be for people with visual impairments who need to use a screen reader, which linearizes all this information. Imagine how confusing it would be when the user's cursor on the top of the empty cell, for example, and the screen reader doesn't see anything. The user might think that they didn't actually press the key or be confused with no reaction. Here's a quick demonstration of how screen reader read web tables. Imagine an author uses HTML tags to create a table online. HTML tag offers many markups to indicate headers, columns, and rows, so that screen reader can understand the structure of the table. The table on the right side shows the results of the HTML tags get rendered by a browser. Suppose that user's cursor is on top of the date cell. The screen reader will read out date. Let's say the user moves her cursor to the bottom cell. Then the screen reader will read out January the 1st. Since this movement was within the same column, the screen reader wouldn't repeat the column name. But if the user moves to the right cell, which is 0, the screen reader will read out the column name first, which is dosage administered date, and then read out the value 0. And suppose the user moves the pointer to the bottom cell. Again, in this case, the screen reader will just read out the value without repeating the name of the column, since this movement was within the same column. In this work, we set out to improve the accessibility of web data tables. We first tried to understand how the current existing guidelines prescribe to design accessible tables, and wish to further understand what makes a data table inaccessible by interviewing people with visual impairments. Based on the interview and the guidelines, we built a Chrome extension that could automatically detect the inaccessible components in the table and resolve the issue by processing the original HTML code and re-injecting them after fixing the issue. Finally, we evaluate our system by analyzing how many inaccessibility issues in a sample set of tables that our system can detect and fix, and by conducting an evaluative user studies. Using relevant keywords in Google search, we collected the existing guidelines for designing web tables. We aggregated the guidelines from multiple sources and found three major emphases from those sources. First, most of the guidelines highlight the importance of HTML markup, such as TH for indicating headers and row group and co-row group for indicating the orientation of the table. Next, some of the guidelines encourage have a summary or caption to provide additional context of the data. Some also pointed out to avoid complex structure. The guidelines were informative, but many ill-formed and complex tables in the wild do not follow the guidelines, preventing people who rely on screen reader from understanding the tables. We conducted an interview with several goals. First, we want to further characterize what factors makes a table inaccessible and derive insights into what types of support users need to better understand the table structure and its contents. We recruited 3 legally blind individuals who use a screen reader daily basis and situated them with 4 real-world tables that are complex. And we prompt them to examine the data in each table and think aloud how they understood the structure and the contents of the tables. Participants were also asked to describe their frustration and possible remedies if they could think of any. We analyzed the participants' responses with the semantic analysis method and further refined them to derive some system-level goals and features. The first goal is to support constructing the mental model of the table structure. And the second goal is to provide additional context to facilitate in-depth understanding. Lastly, the system should facilitate easy navigation. We also define the features that allow the system to achieve the goals, which I will describe in detail on the next page. Again, all the accessibility issues identified here are based on the formative study. First, our tool automatically detects the table's orientation and marks the headers if the header information is missing. This is crucial since screen reader provides header information when users move across the headers. We also further mark up whether it is a horizontal table or a vertical table, as conveying this information is very important for users to construct the structure of the table. The tool also detects the empty cell and injects the word blank to indicate the blank cells. Our tool also can unmerge the merged cell by detecting the overall structure of the tables. In addition, our tool generates the summary by calculating the summary statistics of each column or each row based on its orientation. And our tool offers the filter and sort functions, enabling users to search what they're looking for easily. Lastly, if multiple tables are joined, our tool separates them to make them simple tables. We conducted a performance evaluation by collecting data tables in the wild. We first analyzed how many inaccessible components they have. Total 62 accessibility issues were identified, and we rendered these tables with our tool, and we demonstrated that 98% of the issues were resolved. We also did a user evaluation to further understand the usefulness of our tool qualitatively. We used the same stimuli as the formative study, but this time we presented both the original table and the rendered table by our tool, so that participants could experience the improvement and give us some feedback. Many participants liked the summary feature. It is because they can be more mentally prepared for the upcoming content they are going to navigate. Also, the splitting complex table were well received by participants. The participants were aware of the shortcut to jump around the tables, which is a TK, and they liked the fact that each table is just a simple table. Also, the indication of empty cells solved many participants' misunderstanding. In addition, the filter and sorting function allow participants to search the specific information they want. In addition to that, as P1 mentioned, this function allows participants to discover the trend as well, since you can filter the data by an attribute. In this work, we make online data table more accessible by detecting accessibility issue identified by our study, and fixing the issue on the fly for users who are interacting with the table. We believe that this will also improve the accessibility of other data representations that use table as supplementary, such as data visualization. While this approach has a benefit where we can make legacy table more accessible, we don't advocate that it should be implemented secondarily. We hope to work on developing an authoring tool as a future work that helps authors to make accessible tables by optimizing table structure for both sighted people and screen reader users. Also, with the understanding gained from our work, future work can conduct a controlled experiment to further understand and model the table accessibility based on its structure and context. Thanks for your attention.